This is lesson 3.4, area of a parallelogram. Before you continue, please make sure that you have watched the Brain Pop video on areas of polygons before continuing to watch this video. The reason why I say that is because that Brain Pop video does a very good overview of all of the areas of polygons and how to calculate them. Plus, you can see the relationship between calculating the area of a parallelogram and calculating the area of a rectangle. I'm just going to continue. Now, also too, please have the worksheet 3.4 area of a parallelogram with you because we'll be referring to that and doing some exercises as well. Also, please have a sheet of graph paper, as we'll do one specifically on graph paper because you need to understand how the formula is created for calculating the area of a parallelogram. Now, we'll call this 3.4 area of a parallelogram. Okay, and make sure you have a ruler to underline your title. So again, I'll be going back and forth between the graph paper and this worksheet. There's important vocabulary you need to make note of. When we're referring to rectangles and parallelograms, we refer to two dimensions. So the base is the side of a two-dimensional closed figure, and the common symbol is B. This is what I've indicated on the diagram here. The height is the perpendicular distance. The key here is perpendicular. Remember that perpendicular means that two lines are intersecting and they form a right angle where they intersect. So the height refers to the perpendicular distance from the base to the opposite side. The common symbol is H. Now in the past, when we've calculated the area of a rectangle, we've referred to length times width. Now, to keep things consistent, we'll refer to base and height now. The area of a parallelogram, the formula, is A equals base times height, or A equals B times H. Now, we'll go back to the graph sheet so you understand why it's base and height when you're calculating the area of a parallelogram. Now, I want you to make sure that you are copying the parallelogram on this graph paper as exactly as I do it here on the video. So take your ruler or straight edge tool, and I'd like you to draw a parallelogram that goes, that goes 3 squares diagonal, such as that, and we're going to go 5 centimeters along the base, 2, 3, 4, 5, okay, and then we're going to meet up and do a diagonal like that, 3 squares across, and also there too. Now, because we're working with centimeter grid paper here, you may not necessarily be working with centimeter grid paper, but make sure you have 5 squares across and you have you've cut across, I would say in half, 3 squares that way. Now, what you need to also do is label the dimensions. So 5 centimeters, B equals 5 centimeters here. Oops. Don't know why that's moving. Okay, let me fix that. Okay, redo that. So B equals 5 centimeters. Now this is where we talk about the height being the perpendicular distance from the base to the other side. So what I'm going to do is I'm going to draw a dotted line . So what I'm going to do is I'm going to draw a dotted line from the bottom, the base, all the way to the top here, okay? And I'm going to indicate where they meet They meet at a right angle here. They also meet at a right angle at the top, but so long as it's the perpendicular distance, we know that the height equals 3 centimeters. Okay, so far we have that parallelogram. The base is 5 and the height is 3 centimeters. So when we're calculating this, we know that we always need to set up the formula A equals B base times height. We know in this case the base is 5 centimeters, so we're going to substitute that with brackets times the height, which is 3 centimeters. The total is 15 centimeters squared. Okay, now how can we check our answer and how, because like I said, we're actually taking this height. We're not taking the slanted height, we're taking the perpendicular distance height. So let's estimate the area by counting squares. So if we were to count squares, let me just do this in a different color. Let's say light purple here. Okay, so if we know this, if we count these squares that I'm just shading in here, the full squares, that's 12 full squares that I've just highlighted. So I've got 12 full squares here. This is a way for us to verify our answer. Okay, now we do 12 full squares. Now, we count squares that are almost full, okay? So we count squares that are almost full. I'm going to color those in green. This one's almost full, and this one's almost full, okay? So that's 2 squares. Let's say almost full. Okay, now you count squares that are about half full. So the ones that are half full, I'm going to do in yellow here. So this one is half full, and this one is half full. Okay, that square and that square. We've got 2 half squares. Which equals 1 full square. So our count right now is up to 15. So I'm not going to count the almost empty squares. So, you know, the almost empty squares would be this square and this square. So our estimate is actually 15. So if we add up, if we add up 12 plus 2 plus 1, we actually get 15 as our estimate, which is pretty close to what the area is using the formula. Okay, now let's go back to the page 3.4, area of a parallelogram. The question is from your textbook on page 109. It says, Kate has created a tulip garden in the shape of a parallelogram. She's going to plant 10 tulips per square meter of garden. Her garden has a base of 8 meters, and a height of 5 meters. How many tulips does she need? So the first step, you want to draw a labeled diagram of the garden below. So I just had to reopen the document in Notebook here. So to do that, we are going to draw a labeled diagram. So we're going to draw our parallelogram. Again, it doesn't have to be to scale because we are just going to label it. So we know the base is 8 meters. The height is 5 meters, so make sure you're doing the height properly. So indicate that it's the perpendicular distance here. And we want to indicate that with a rectangle, it's 5 meters. Okay, how many tulips does she need? So we need to calculate the area of the garden first to figure that out. Remember, when you're calculating the area of a parallelogram or any formula, you start off with the formula itself, A equals base times height. The base in this case is 8 meters. Show your substitution in brackets, times 5 meters. We know our final answer is 40 meters squared. Now, I just want to make sure. Okay, so we have units. We've made sure that we have indicated the units, 40 meters squared. Now, what we're going to do is we're going to figure out how many tulips she needs. If we know that according to the question, she's going to plant 10 tulips per square meter of garden, and we've got 40 square meters of garden in total. We're going to do 40 meters squared, which is the area of the garden, times 10 tulips per square meter. We know she needs 400 tulips. So Kate needs 400 tulips. So just a reminder again, please make sure that whenever you are calculating anything that has a formula, you always show the formula. You start off with the formula, you show the substitution, circle your final answer, and don't forget your units. Now for bigger numbers, if you need to do your calculation off to the side, you can. The area of a parallelogram, again, and this is something that you should memorize eventually, is A equals base times height, or A equals BH. Remember too, we went over y. We're looking at the perpendicular distance. From the previous question, we estimated that the area of the parallelogram in this case was actually quite close to what the actual calculation was. That's why it's appropriate to take the perpendicular distance here.